Gurubhyo Namaha. In today's session, we are going to learn about abnormal molar masses and Van 't Hoff factor. In the previous sessions, we have studied about various colligative properties and how to determine the molar mass of solute particles using the colligative properties like relative lowering of vapor pressure, elevation of boiling point, depression of freezing point and osmotic pressure. Today, we are going to understand what is abnormal molar mass and Van 't Hoff factor. In accordance with the previous knowledge, colligative property is a quantity that depends on the number of solute particles present in the solution, which means colligative property is directly proportional to the quantity of solute present in the solution. In other words, we can say that colligative property is inversely proportional to molar mass of the solute. Let me explain this in detail. Now, when 1 mole of NaCl is added to a solvent, it dissociates into Na plus and Cl minus. Now, colligative property, which is dependent on the number of solute particles, in this case is 1 because 1 mole of NaCl is added to the solvent. So, this 1 is the theoretical value. Now, after going into the solvent, this NaCl splits up into Na plus and Cl minus. So, now it has become 2 particles or 2 parts. So, this 2 is said to be the absorbed value. So, 1 is a theoretical value because 1 mole of NaCl is added into the beaker to the solvent and it dissociates to give 2 particles or 2 quantities. So, this 2 is the absorbed value. Now, according to Van 't Hoff factor, I, which is equal to absorbed colligative property divided by theoretical colligative property. Observed colligative property is 2 because it dissociates into Na plus and Cl minus ions. By theoretical value is 1 because only 1 molecule of NaCl is added to the solvent. So 2 upon 1 gives 2. So this Van 't Hoff factor I, which is greater than 1, indicates that the added electrolyte undergoes dissociation. Remember, when the Van 't Hoff factor I is greater than 1, it indicates that the electrolyte has undergone dissociation. Let us go for the second example, benzoic acid. 2 molecules of benzoic acid in benzene. 2 molecules of benzoic acid added to benzene undergoes dimerization, which means 2 molecules of benzoic acid dimers by means of hydrogen bonding. Now these 2 molecules have become 1 molecule. So this 2 is the theoretical value, whereas after dimerization it is said to be observed value. So what is the colligative Van 't Hoff factor? I is equal to observed colligative property. See, look at the formula here. Observed colligative property, the value is 1 divided by the theoretical value is 2 because 2 molecules are added to benzene, but in the benzene the 2 molecules become a single molecule due to dimerization. So I is equal to observed colligative property 1 divided by theoretical colligative property 2, which is equal to 0.5. So I value is less than 1. This indicates that the given electrolyte or the given component is undergoing association in benzene. So whenever I is greater than 1, the electrolyte is undergoing dissociation. When I is less than 1, the solute is undergoing association. Now what happens when I is equal to 1? Then in that case, neither association nor dissociation takes place. Neither association nor dissociation takes place. In that case, I is not an electrolyte. The nature of the solute is non-electrolytic solution. Now let us look into the table to have a clear idea about dissociation and association properties of a solute, which is the reason for revealing abnormal molar masses of the solute. Now dissociation, as I told you earlier, NaCl undergoes dissociation to give Na plus and Cl minus. So the quantity of the solute has increased from one molecule to 2 particles. So in dissociation, the quantity of the solute has increased. When the quantity of solute increases, the colligative property also increases because these two are directly proportional to each other. This is also indicated in the first introduction part itself. Colligative property is directly proportional to quantity of solute. So as the quantity of solute increases, colligative property also increases for dissociation. Now what happens to the molar mass of the solute? When these two are increasing, the molar mass of the solute decreases, because when 1 mole of NaCl is added to the beaker containing solvent, it splits into 2 parts. So it is assumed that the molar mass of the added solute is decreased. So molar mass is decreased. So what happens to Van 't Hoff factor I? I value is found to be greater than 1, which was discussed before itself. Now coming to association, quantity of the solute during association is going to decrease because 2 molecules of benzoic acid dimerizes, so number of molecules are decreased over here. So quantity of solute decreases, as a result colligative property also decreases. Now what happens to molar mass? When they undergo dimerization, obviously the molar mass of the product is also going to be increased. I value is going to be less than 1. Right? So these are the properties of association and dissociation of solute particles. Now we have to look at the modified equations for colligative properties after introducing the Van 't Hoff factor I. What is I? I is nothing but observed colligative property upon theoretical colligative property. So relative lowering of vapor pressure is equated to I into Xb. Similarly, elevation of boiling point is equated to I into Kb into m. Depression of freezing point is equal to I into Kf into m. And osmotic pressure is equal to I into C into R into T. So these are the modified equations for colligative properties after introducing the Van 't Hoff factor. Now what is the significance of this Van 't Hoff factor? Van 't Hoff factor I is used for calculation of the extent of association or dissociation. Association or dissociation of an electrolytic solution. What is meant by degree of association and what is meant by degree of dissociation? Degree of association or dissociation can be calculated from this expression. Number of moles undergoing association or dissociation divided by total number of moles taken will give you the degree of association or dissociation. This formula is very important for this further calculations. I told you earlier, the degree of association or dissociation can be calculated by number of moles of particles which has undergone association or dissociation divided by total number of moles taken. Now let us discuss the degree of dissociation, which is indicated by the symbol alpha. Now let us take AN to be the reactant. N is the number of moles or number of particles, which is said to be a weak electrolyte which undergoes dissociation to give N is the number of moles of the product. Now at T is equal to 0. When T is equal to 0, the number of moles or number of molecules of A is 1 and there is no dissociation taken place. So here it has to be 0. After some time T, 1 minus alpha. Alpha is the number of particles which has undergone dissociation. So 1 minus alpha in the reactant side, and in the product side n into alpha, because the number of particles dissociated is indicated by alpha. So in this place you are supposed to put n alpha, because over here it is mentioned as n. N indicates the number of moles of the particles. Now I is equal to observed value or observed colligative property by theoretical colligative property. So on adding these values, 1 minus alpha plus n alpha, these are said to be the observed colligative property, and this one is the theoretical colligative property value. Substituting these two values in the expression, we will get 1 minus alpha plus n alpha is the observed value, divided by this 1 is going to be the theoretical value. On simplifying this expression, we will get the degree of dissociation is equal to I minus 1 divided by n minus 1, where I is the Van 't Hoff factor and n is the number of particles or ions present in the solution. Now, degree of association, which is called as actually dimerization. What happens here? What is the relation between Van 't Hoff factor and degree of association? For better understanding, I have used the alphabet beta. It can be also alpha in this case. Degree of association, that is n number of A substance. It's a weak electrolyte, undergoes dimerization to give AN. So when time t is equal to 0, the number of molecule is assumed to be 1, and there is no association of molecules taken place. After some time t, 1 minus beta. The beta indicates the degree of association that has taken place after time t. So here it should be beta divided by n, because molecules are undergoing dimerization or association. So it has to be mentioned as if two molecules are on the reactant side, it becomes half of it. It becomes 1. So it has to be written as beta divided by n. So I is equal to observed value divided by theoretical value. Again, 1 minus beta plus beta by n. Beta divided by n. This is the observed colligative property or observed value. Upon this is the theoretical value. So on substituting this, I is equal to 1 minus beta plus beta divided by n. Taking this 1, the other side it becomes 1 minus I is equal to beta into 1 plus 1 by n. Taking the beta out to the left side, it becomes 1 minus I into n divided by n plus n. Or further simplification, it gives beta is equal to n into 1 minus I upon 1 plus n. So degree of association can be expressed using this formula. So in a simple term, you can understand that degree of dissociation, you will write the expression as 1 minus alpha plus n alpha. For degree of association, you can write 1 minus alpha plus alpha divided by 2. So these two are same except for the last term. So that's all with the content. You are supposed to go through the NCERT content line by line for proper reinforcement of the chapter solution. Thank you.